So now we have P, a mathematical statement, and this statement is going to have a property is that it's either true, and we denote true by T, or false. Okay, so false we shall denote by F. All right. Now if we write negative P, it's called the negation of P. So when P is true, negation of P is false, and vice versa. So let me just show it to you in a truth table. So this is the truth table, and here we have the first column for the values of P and the second for the corresponding values of a negative P. So as we said before, if P is true, then the negation of P is false. Okay, and if P is false, the negation of P is true. All right, so that's how these correspond here. Now we are going to connect different statements through logical connectives. Now if we have two statements P, Q, we can connect them through a logical connective called P or Q, or the connective is or. We also call it disjunction. Okay, and disjunction, or this portion, or a symbol for this is this symbol right here, and this stands for P or, I'm sorry, this stands for P or Q, and P or Q is it's false only when both P and Q are false, otherwise it is true. So if we have to prepare a truth table for this, it will go like the following. So we can have values for P and Q in the following manner. That is, both P and Q can be true, or we can have P as true and Q as false, or we can have P as false and Q as true, or we can have both of them as false. So what we have here, that is, if we have this, if both P and Q are true, then we shall get that P or Q is true, right? Okay, just a second, what got messed up here? Sorry about that. So here, so in this case P or Q is true, and here they are true again because they are false only when both these are false. So this is still true, and here what we have, it is false. So this is the truth table for P or Q. Now let's look at another type. So in this case we are going to look at P and Q, and a symbol for and is this symbol called conjunction. Okay, and what we have is that this if we look at this P and Q, all right, sorry, P and Q is true only when both P and Q are true. All right, otherwise it stays as false. And you can look at analogies, or if you want, you can just think about it and it will look quite natural to you. Okay, so let's construct a truth table for P and Q according to the variation in the truth values of P and Q. Okay, so as before, here are various possibilities of values of P and Q. So if both these are true, then it will be true according to the rule that we have. If any of them or both of them are false, then P and Q is false, and in these cases these are all false. Okay, so this is the truth table for P and Q. Okay, So now we are going to look at this compound statement. P implies Q, and the symbol for implies is this. And for this you have that P implies Q is false only when P is true and Q is false. That is, we don't, we don't let the implication be true even though the premise is true. All right. Or you can just, make up examples and verify that. All right. So we will now construct a truth table for this. So now in this case, what happens is that the statement is true when both of them are true. Now here, if P is true and Q is false, then the whole thing becomes false, and we don't mind P being false and Q being true. Implication is still true, and if either of them are false, still the implication is true. Okay, so this is a truth table for P implies Q. Okay. Now let's take up an example in which we have to make a truth table for this statement. P implies P or Q. So what we shall do for this, that we already created a truth table for this, so we'll go ahead and build up on that. So here is the truth table for P or Q that we had created just a few minutes ago, and we are going to use this to obtain the truth table for this statement. So notice this. Here we want to look at the corresponding values of this column matched with this column. So here both of them are true. So what shall you have? You shall have that this implication is true. Then what happens in this case? This is true and this is also true, so this becomes true again. Now in this case, P is false, P or Q is true. False implies true is still considered as true. Okay, and here both P and P or Q, both of them are false, and in that case implication is still true, right? So in this case what happens is that the values of this statement stay true regardless of the truth values of its ingredients. So what we do is we call such a statement as tautology or tautology, whichever way you want to pronounce it. All right. So let's look at a truth table for this statement, this compound statement. And here we have negative P implies P and Q. So we had created a truth table for P and Q. So let's bring it in here. So we are bringing that in. Here it is. I'm sorry. So what we can do is, since we are looking at this implication, let's do this. That is, bring them over here. And in the middle, we will just insert a column for negative P. I mean, you could have done it in a little better aesthetically, but that's all right. So here we have negative P. So let's fill this column up. Okay, that is, see, both P is true, so negative P would be false. P is true again, so that will be false. Here P is false, so this will be true. Now P is false, so this will be true again. So that's how these values match up, right? Okay, so then we will go ahead and create a column for who? Create a column for this statement, whose column we had to write. So we got this. One moment. Okay, let me just extend this. And now we are going to be confined to this column. Oh, one moment. To this column and this column, well, they are adjacent columns anyways. So here what happens? This is false, this is true. So in that case, this implication would be true. And now both of them are false, so implication is true. Now here premise is true, the consequence or implication is false, so that's going to be false. Okay, and here also we have this as true and implication is false, so that will be false. Now here we have, in this column we have both T's and F's. So what will happen is such a statement is called a contingency. And in case we had all of these as F, then it would have been called a contradiction. Okay.